Now I want you to implement the depth-first traversal on this graph. The implementation is very similar to what we had in the section about trees, because as I told you before, a tree is a special kind of a graph. So here we need a recursive method that takes a node object, it will visit that node and all its neighbors recursively. Now, as part of this, you want to make sure that you don't visit the same node twice, because in graphs, it is possible to get to the same node via different paths. For example, look at the C here. We can get to the C from the A or from the D. This never happens in trees, so we didn't have to worry about it before. But here we have to handle this scenario. So we want to make sure that we don't visit the same node twice. And that's really easy. What data structure do you think is suitable for keeping track of the nodes we have visited? We can use a list, but lists are not ideal for looking up an item because finding an item in a list runs in linear time. How about the hash table? Hash tables are good, but we use them to store key value pairs. In this case, we don't really have key value pairs. We only have keys or values, whatever you want to call them. You want to know what nodes we have visited. The ideal data structure here is a set. We covered this in the first part of the series. A set is like a hash table. It allows us to look up an item in constant time, but it only stores the keys, not key value pairs. So go ahead and spend 20 minutes on this exercise and come back seeing my solution.